So let me welcome all of you to the fourth webinar session of the WHO SERO Responsible AI in Healthcare webinar series, organized by the Koita Centre for Digital Health at Ashoka University. My name is Gautam Menon, and I will be moderating this session. A question that lies at the core of debates about the use of health data is, how do we protect the rights of individuals to their privacy and personal health information, while recognizing and maintaining the importance of this data to innovate for the greater good of both personal and public health? In other words, how can we provide protections against the misuse of data without strangulating data flows? This question is particularly important in the age of AI, where we can begin to detect patterns and structure in very large data sets that are simply not detectable in smaller data sets. And this question is interesting because it raises interesting ethical and moral issues as well as purely technical issues. This webinar will concentrate primarily on technical issues involved in advanced AI architectures that treat data privacy and confidentiality as central concerns. So it's titled Advanced Architectures, Federated Learning, Privacy-Preserving Methods, and Edge Processing. The questions that we'll address are, how do we handle data in place? How do we appropriately anonymize? And how do we share health data? So the structure of this particular webinar is, we have a keynote address that will take approximately 20 minutes. There will be a panel discussion that follows for about 20 minutes. And then we will have a country spotlight, in this case on Thailand. Then I'll finally try to summarize all of our discussions together within these 45 minutes to an hour, with some closing remarks right at the end. I'll introduce each speaker and panelist extremely briefly just before they start, and I hope everyone will keep to time. So let me begin by inviting our keynote speaker, Professor Mary Ann Hartley, who is director and founder of the Light Laboratory, which is a laboratory for intelligent, global health, and humanitarian response technologies. Professor Hartley is a pioneering researcher at EPFL and Lausanne University Hospital. Professor Hartley's work explores how edge and federated AI can be deployed safely in low-resource and humanitarian contexts. Professor Hartley will speak for about 20 minutes about privacy-first intelligence, rethinking AI architectures for global health. Professor Hartley.
Thank you so much for the introduction and also for the opportunity to speak here. Very excited to have that opportunity and also take you through some more practical ways to address this problem and not always feel stuck, that we just speak about problems and not about real-world actionable solutions. So I hope that that's what will come through today. I'm showing my screen for a second. There we go. And you should be able to see it. So I'm going to try to deliver exactly on the title as was provided, to speak about some advanced AI architectures for public health that allow this kind of privacy-preserving utopia that Professor Menon just alluded to. I'll be speaking about federated learning and some other keywords that are important to know about. Privacy-preserving models. What is privacy in this world of large language models, where models are so big it's very difficult to make them forget things? And what is edge intelligence? And are we anywhere close to that? So I will just quickly expand on the introduction, just to make sure that if you ever want to reach out to us for some of these pragmatic solutions, you do feel welcome. So as was said before, the lab is called Light, for the Laboratory for Intelligent Global Health and Humanitarian Response Technologies, based mostly in, I'm South African, so I have a little bit of an African bias, but actually based in, as you can see over here, in Switzerland, because it's a School of Computer Science there, a lot of computing infrastructure, and a lot of very sensitive data and partners that handle sensitive data are based in Switzerland, because it's really this hub of humanitarian action, working in war zones, volatile environments, and we work a lot with them, as you can imagine, from our humanitarian aspect. So it's a personal concern to us, and we've made some tried to at least make some pragmatic solutions. We also are based at Harvard School of Public Health for our clinical trial aspect. So you can see we actually also have to deal with real world data coming in, and it's become a pragmatic concern for us as well. and then very happy to be hosted at Ashoka University in a faculty position there at the Koita Centre for Digital Health. And we're working with the Ministry of Health, ICMR, and then also in Rwanda. So what we're trying to do in general, just to frame it so that you'll see what we are speaking about. In our group, we really try to have these like scalable and very much implementable tools that are provably impactful. That means that we do like clinical trials, right? So this is the representation for this like data collection, clinical trials, and then to make sure that we are doing collaborative AI, so we co-design. I know those sounds like very fluffy words, but we have tools for these things, and we're running the trials. So this kind of clashes often with this. We actually take a very extreme approach to openness to make sure that we have all the tools that are very much open and are neutral, in line with humanitarian principles and with the principles that the WHO has been pushing for a long time about open science. And so this kind of approach requires certain technical changes. And we try to make our tools as agnostic to the data as possible so that when we do open them, they're useful, right? Agnostic to the model as possible so that when we do release a tool, it can be used in any kind of model. So it's not like locked in, right? So these are just some of the principles we have. So when I just break these down, these little like diagrams, that they're representative of something. So over here, when we're doing clinical trials, we make like these platform trials that try to, again, be agnostic to the geography then, and they try to be able to expand across different places. Now, this creates a problem because here we have data crossing borders. So how can we really make these privacy-preserving tools that have to adhere to these very high standards, clinical standards, and also between geographies? It's a very hard problem that we have to solve, and I think a lot of people on the call would be also kind of facing the same problem as well. In terms of the once we have the data, right, this then becomes a real central problem. And what we do here is we make tools that fulfill this kind of purpose of distributed collaborative learning, which is what we'll be speaking about today. It's in the title. It's the federated learning component of what we are doing, and it's federated learning falls under distributed collaborative learning as one of the methods. So just trying to show a very practical tool that we have that is actually ready to use, and very happy to speak with people who are interested in using it. Then once we allow people to kind of make models without giving up the ownership and privacy of their data, which you will see soon how we do that, then you can make models, and those models can be private. But can they be? If a model is actually a conversational interface, like our tools, for instance, like Meditron is our large language model for medicine. If it's a conversational interface and you can literally just ask any question going, hey, does this person have this disease? How private can it really be? So what are the methods, even when you don't reveal the data directly, what are you learning in your probabilistic kind of next word prediction of these large language models that makes the model itself private? Even if you keep the data private, are those statistical associations really kept private as well, right? So the answer is no, and we've seen many examples of that. So how do we deal with that? And then finally, when we do inference, this was this edge intelligence that we were speaking about before, and this is really more about like how, when we have these models, do we ensure that they are it's a like trustworthy, that we have guardrails, and that there's an ownership and a control that allows us to maintain our standards of privacy. Okay, so if we get stuck in, we want to kind of, again, start with this federated learning. This is the content, as I said before. Then we'll go to what is privacy in the age of LLMs, and then we'll do this edge intelligence. So just following that framework. So in terms of what's distributed collaborative learning, and as I said, we have this tool called Disco, which I'll show you how it works, and you're welcome to go use it as well. Well, it actually comprises a few things, but it's important to know what it is by knowing what it's not, okay? And what it's not, distributed collaborative learning, is not centralized learning. So this is how we are normally doing things, and most people approach making models like this, where you have several users in different countries, for example, and they all have data that's relatively similar, but there may be some biases that you'd want to figure out, but they are distributed across different settings. And now you want to make a central model. So what do you do? Well, you Control-C, Control-V, and you put that all into a server. And you hope that the anonymization processes that you have worked. And this server is the place where you would train your model, for example. And this Control-C, Control-V thing is used a lot, and I hope that it becomes out of fashion at some point. There's this big call for, big data repositories, centralized data sources, and people are understanding more and more, especially with global health in the public health space, that data is absolutely an asset, and to give it up is just simply unfair. And that relies on like a trust that sometimes can't be upheld, because privacy is a concept that degrades over time, right? So there's this loss of ownership that all of these users will feel, and it's a little bit unfair, and it's usually like imbalanced in terms of like higher resource setting, lower resource setting. And this intellectual property is something that's becoming increasingly important, especially in implementation sites. But what's important is that it's super laborious to make sure that you are actually anonymizing these data and sharing it in an interoperable way, and ends up that people are really disincentivized by these processes, especially the one that privacy is something that does degrade over time. And as models are improving, it can actually degrade whether it can stay in place or not, right? So your efforts may be removed, and you can have some sort of like regret later, So all of these things are very tangible and real disincentives to share data. And then we start to see that the data becomes unrepresentative. And why and where? Well, it's because it's disincentivizing, but it's disincentivizing to those who have the least resources, for example, to be represented. So people who are underrepresented in data often don't have those resources, and then it's just a compounding issue where the models then end up being unrepresentative as well. So this is a cycle that has happened over and over again. And now it's what we're trying to do is then to flip the narrative and say, well, let's remove those disincentives and do something with federated learning. And you saw there, it kind of like tries to flip the narrative. So instead of sharing the data to the source of the model, what you do is you share the model to the source of the data. Right. So now you can see the model in all of these places, and everyone wins in this scenario, right? Because everyone's getting a model and the data is kept in place, right? So even the server or the central place will get the model and the insights from the data without actually taking the data away. And so this retains ownership, and it's a shared intellectual property that's in the model, that's hosted in this model. And it's less laborious. It's not completely unlaborious, right? To do this, it's not like an easy ride, but it's technically could be easier, which would be less disincentivizing. And there's a significantly reduced privacy risk. Now, it's not eliminated, but you'd have to try a lot more. You'd really have to be motivated to go against some of the systems that are in place for privacy preservation in federated learning. And that extra motivation is actually very important, and you're trying to create friction toward people revealing the data, right? So how does this really work? Well, what happens is when you've like put the models in the different data sources, this is where the model is going to be trained. You can see it's training in place, and it learns from the data. And these things that are coming in here are just like abstract updates that are being sent to a central model that then gets aggregated and sent back to each of these models. And now you've actually learned, right, the same, provably the same model, right, without sharing any data. So you've distributed the computational power, and you've allowed them to use their own local servers or local computers, even some models don't need that large amount of data to train the model. And so this is a very standard concept. It's been around for a long time, at least in industry, but the global health and public health community has been slower to adopt it because there's just not a big understanding and regulations around it, which I think need some good use cases to prove the point, right? So just to recap, that means that the model is distributed from the server, just to make sure that we understand the key points here. No original data is exchanged, okay? And then that's no original data is exchanged between partners. and only these abstract representations of data are shared. So the model learns locally with shared computing power. And this obviously it means that we do assume certain things. And this abstract representation, some people have pushed back on saying, hey, well, you can actually learn from this gradient, this abstract representation. And if you really, really are smart and you're obsessed with federated learning and you're an expert in this field, you could learn from the gradients that are being shared. And this is called the gradient inversion attack, for example, where you could then reproduce the data technically. So now, does that mean that this is like is it worse or better than sharing your data that you think is private? Well, it still is it's not an intractable problem, right? So there's been several kind of defenses that have been made against this re-identification attack, and several of them work well. I mean, I'm not going to go into detail here for this. I don't think there's. I believe that there's a very interdisciplinary crowd here, so I've promised no equations, and none will be revealed. I swear. But here, different things that you could do here is you could like add differential privacy, which is noise to the little bit of noise, right, to the gradient, and so you can never really find out what the original gradient was. And you can also like add encryption, that's everyone knows what encryption is. And you could also it's a kind of a different way to add noise. You just like you round up or round down the gradient. So this is like the number that is this abstract representation. And it also doesn't allow you to have that like direct like connection to the original data. And then there's something called secure aggregation. I put a little basket here because you can aggregate the gradients from different parties, and in a way that makes sure it's secure multi-party computation, in a way that you make sure that you either don't know where it came from, or it's impossible to know what the original thing that was shared. So you add like an arbitrary number to each person's gradient, and then you kind of make sure that it evens out at the end, but you don't actually know, no single person knows, not even the server knows what the original number was, right? So these are some clever ways of doing it. So it's certainly not an intractable problem. Nevertheless, there are some bottlenecks over here with federated learning, and when we are thinking about this from a public health perspective, distribution of like the tasks are always like desirable, right? But still, this bottleneck is potentially a central point of weakness if it's not a very robust one. So what we can also do is we can go even a step further and do totally decentralized learning. Now we must remember that like these things are not, like, as I said, these things are not new. They need to just be implemented, and you can advance them in various ways. But this is how like predictive text has been working, like on your keyboard and whatever, how it learns. So we know that these things work. It's not like this thing in the future that we're speaking about. It's really now, and it's the time to use it if we really want to deliver on this privacy preserving stuff. So we can also go further and even have no central server and just be peer-to-peer completely, where we eliminate further eliminate. Not eliminate is a strong word, but reduce. There's still problems here, of course, because remember, we're distributing compute. We are assuming people have compute, so maybe this person's GPU is really slow, or maybe they don't even have one, right? Maybe in a low resource setting, there's unreliable communication, right? And you have to wait and be more robust to asynchronous training between partners. And the big problem is really trust, right? How do you trust? Trust what? Trust that people have good data. People were always complaining about black box models. Well, now you've got black box models that you are making plus black box data. So now how do you feel comfortable about this? If you can't see the data, are you comfortable? Because someone may be a malicious actor and just poisoning the system with like purposely trying to mislead you, right? This also happens when you share data openly, right? Maybe poor quality, and that certainly happens when you share data openly as well. These are not new problems. But there also may be imperfect interoperability, which is something that all of these things we can try to test, even if we can't see the data directly. So as I said, not intractable, and we've made it some just to make it more feasible before I show you how we address some of the interpretability things. You can actually go here to Disco. It's a distributed collaborative learning platform. Super simple to use. I'm going to quickly stop sharing, and well, you know what? I'll stop sharing now, and then I was going to take you through like I'm going to show you actually the actual platform, right? Just quick, and then I'll move on to the last bit, because I think I only have 20 minutes, right? So just quickly do this. So If you can see here, the Disco platform, you can see who it's targeted towards, right? So if you wanted to use this, and please feel free to contact me. This is an open, kind of demo platform, so you can see it and it works, right? So the models that are on here are good, and they work as a demo. And then here you can see like train models together, keep data private, build AI models and without sharing any data, and it's directly in your browser. So nothing leaves your browser, and you do this on your computer, on your phone, etc. This does mean that it's smaller models. You can't train like a large language model on this or something, but most models that are useful for us currently in the field are smaller models, right? So maybe like X-rays or something. So very simple. You start training. This is just like a little tutorial, so we can block that. And there's just like a few steps. So you first select the task. So there's like some Disco collaboratives, we'll call them, which are models that we've pre put up here. So maybe we'll do the lung ultrasound classification model as an example model here we have. And then you'll go and see, you'll click on it and go, I like this model, I'm going to contribute to it. And then it's you just clicking. You can go read about the model if you want to, but you don't need any AI expertise to participate. You need data and you need to understand your context. And now that you can read the task description about what this model is looking at, it's trying to diagnose, I think, COVID here from lung ultrasound. And you go, great, I've got data and my data looks like this. And you're going to now connect your data. So the model, you're going to show the model where your data is. The model's coming into that space in your browser. And like when you are opening a PDF in your browser, right? It's not getting published on the World Wide Web or something. It's in that space on your browser, used as this interface between the internet and your computer. And this is where the model comes, and it trains using your web GPU. So you just can drag and drop your data here. You're not sharing it. You're showing the model where the data is, so you're sharing the path. And then the model trains directly in your browser. So you just have to come here and you can say, well, I want to train on my own. So you can just go, I want to train locally. I don't care about other people. So it's just also a place where you can use the model. And then you can also train collaboratively with any participants that happen to be online for that participation. So, and then you can start training, and you can immediately see the model training over here. So that's quite cool. So because I've only have a little bit of time left, as I understand it, I'm just going to share my screen for the last thing. I wanted to make sure that we got through that, because that's a pretty cool use case of the yeah, it's this one. Cool. Got it. I'm here. Okay, yeah. So that's just something that you can use all the time. I think I'm sharing the right screen, so it looks good. And this was just like a video of how it works. And actually, when you are uploading data, you can upload data, and then you can see the model training. So this is kind of cool. Just the thing that I didn't show you is when like two users side by side are training the model, and you can see them training together. It's pretty cool. Won't go into that, but they'll go directly into like how we address the black box issue. It's not intractable. We found some ways, even when you don't see the data and you know that there's a bias in one person that you don't see, you can actually go ahead and see the differences without looking at the data. How this works is we've got this my this, your that framework, it's called, right? Myth. So what we do is we train a model on one hospital where there's a bias, where there's no bias, and another hospital where there is. And we know that we don't want to learn this over here, where every time we want to diagnose pleural effusion, there's this like drain that's going to be there, and we're actually detecting the presence of a drain rather than pleural effusion, for example. So when we have this kind of like red herring that we want to ignore, what we do is we put like an emoji so that it's more obvious, because some people can't see the drain. So we just made one that's got an emoji every time we have a bias. So it's this label leak. And what we did is you can just basically see you train, and then you've shared no data, and your model recognizes the correct and appropriate place where it's supposed to look. This was for like cardiomegaly or something. And the biased model looks at something that's completely irrelevant, which is this emoji. And then when you swap models, which is as simple as that, swapping models, you can see that the model over here is focusing on a useless place, where this model is focusing on the right place. And then you can use this distance, because you overlay them like that after you've swapped them. And you can use the distance to see how relevant the data is for you, and then learn the features that you want to learn from the people that you want to learn from. And with this interpretability, you're actually understanding which users in a federation are useful for you, and why. So a very visual representation of why and how they would be useful to you, right? So, and then you can learn a global model that is more relevant to your setting, right? So that you can learn the useful things from each of the people that you are working with. So that was just a little side quest. So then in the last, I would say if you can give me 2 minutes, I just wanted to put some words in your vocabulary about what is privacy in the age of LLMs. Well, I would say that models are data. Your data is going to be inside of these models, and they are huge, and it's difficult for them to forget things, right? So I think that is very important. We are making these models that don't rely on medical data for that specific reason. So we make Meditron, for example, which relies on public data, and we have some pipelines to scrape the public data so that the model is provably doesn't have any data in it. So that's one way of making them private, is not relying on medical data, but rather on guidelines and medical rules or something, right? And just an example, if you want to go look at this, we have a fully open model. It's actually the world's first fully and truly open model. This was made in a collaboration between different 70 or so professors in EPFL and ETH Zurich, where they actually made this not only open data, which is very unique, but it's actually fairly sourced and it respects copyright data. So what they did, which was very impressive, which are my last slides then, is these things are very, very cool, is that they trained not only on open data, but they trained in a way to forget the data. So they've done selective forgetting of the data that they trained on. They also made sure that they punished the model when it was verbatim. So that was an example. So they punished the model to reduce the probability of verbatim recall. And then they also did unlearning to afterwards, after they did train it, they didn't do this specifically, but you can unlearn information that you have accidentally learned, right? So this is another thing, another word for your vocabulary to take home. And the last one that is interesting is this differential privacy, which you've heard about before, but just applied to LLMs. So to apply noise, so you can see like how expensive this is to do with how much it costs and how much noise you put in. And there's a sweet spot to get it right. You don't want to put too much noise in. But basically you can have this increase of plausible deniability of whether you actually learn that or not. Okay, so all of these things are problems, sure, but they're not intractable. And some of them are very practical and have solutions. And I hope that at least with this little tour of the ways that you can approach privacy in this new age of LLMs, that it has at least brought some clarity to some of those issues in public health and like federated learning settings. So thank you. I'm only 5 minutes over, so I thought that that was very good for me because I'm very talkative. So I'll stop here and welcome your questions.
Thank you, Annie. Thank you for really setting the stage for everything that's going to be discussed from now on. And also for the quick demonstration of the DISCO model. And I think it's interesting that to use it, you don't need AI expertise. What you do need, as you said very correctly, is that you need data and you need the context. And I think there were two things that you mentioned that I think are particularly important, and I quotes as well. The data is an asset, giving it up is unfair. And privacy is the concept that degrades over time. That's again an important point to make for us. So let's just go on till we get to the panel discussion so that everyone has enough time to speak about this. As I said, the main question that we want to address here is how do we protect the right of individuals to their privacy and personal health information while recognizing and meeting the importance of this data to innovate for the greater good. So what we have now is three outstanding researchers who will provide their own perspectives on this question. So Dr. Praneeth Vepokoma, Dr. Tapate Sethi, Mr. Sanjay Varma, who are our panelists. I will ask them to speak for between 3 and 4 minutes on the questions that I put to them, and then we'll circle back to each briefly to refine their answers or to explore adjacent topics within the time that we have left. And I'll summarize briefly at the end of that. So let me begin with Professor Praneeth Vepokoma, who is Assistant Professor at the Mohammed bin Zayed University of Artificial Intelligence at the UAE, as well as Visiting Assistant Professor at MIT in the USA. He's an applied researcher who works at the intersection of privacy-preserving machine learning, distributed AI systems, and edge computing. So the question that I'd like to put to you, Dr. Vapakuma, is how can federated learning be adapted to health systems in low resource settings while ensuring data protection and interoperability? Go ahead.
Yeah, it's a wonderful question. Thanks, Gautam. I'm very glad to be here and enjoying the whole program so far. Okay, so to get to the point of your question has multiple facets or dimensions to it. When we use the word low resource, right? As also Anne kind of referred to in her talk. So it's good to enlist that and think about these are the hammers, these are the nails, and how do we kind of match this to solve the low resource problem, right? So there is one set of low resource problems that is low in terms of data resources, right? You could have clients which have very few samples of data. You could have an extreme case where the client uses a cell phone and they only have one single sample of data. For example, it could be a time series of their health tracker on their cell phone, right? So this is the low resource setting from a data perspective. One could also be low resource from a computational standpoint, right? So they could be low in compute, where they cannot maybe fine-tune a large language model, but maybe they can't even do linear regression. Maybe the compute is so low. Or they could be low in terms of communication bandwidth, which is the amount of upload and payload that you could do in terms of whatever sort of smash data or gradients that you are supposed to communicate as part of the federated or like a distributed learning protocol. So and then there is a heterogeneity of these resources too, okay? And that leads to fairness problems, okay? And then there's a question of privacy. There are hammers for privacy, but there is, in terms of low resource setting, there's a question of can the right person bell the cat, you know? Uh, is someone well resourced, practically speaking, to implement all the technical solutions to ensure some sort of a privacy mechanism is in place. So this is not a single problem when we talk of low resource. This is a whole gamut of problems. So different problems now have different nails. So let me just list down in the next minute or so a bunch of nails and so sort of trade-offs that you're playing with. Not a list of nails, a list of hammers to hit these nails and the kind of trade-offs that come into play. Okay, so one important setting is the extremely low data resource set, low data setting, right? If you think of fitting a linear regression, forget a complicated model, and if every client has a single sample, this would not work well. And even if it worked, it would converge very slowly, basically. Your optimization will go almost forever. And it's kind of very easy to also have a visual cartoonish reason for this, apart from more technical reasons. If you're trying to fit a line, right, which is a linear regression, you have a single point. There's infinite possibilities on each client. You need at least 2 points to fit a line. Not that two is good enough. You need enough samples so that your model that you're learning on each client doesn't have too much variability as you aggregate and continue to converge in this federated sort of protocols. Okay, so this kind of flips the question of how to do some sort of a variant of distributed learning in here as opposed to traditional federated learning. We, for example, at our lab have introduced something called modulated learning, but basically it falls, the kind of solutions in here fall under don't share the model in the traditional sense, where the models are referring to the model coefficients or the numbers or the weights of the model itself, but share some sort of a transformation of your data that is not a model in the traditional sense, right? And then the transformation of the data is aggregated at the server, some more post-processing is done, and you kind of ideally try to estimate in an unbiased fashion the model that you would have got in the centralized non-private setting. So that's the golden optimality that you're trying to reach out for. So kind of don't do traditional FL, do variants of it as the solution. At the same time, let me conclude. I mean, so this just gives a feel for what it means to tackle low resource problems, right? There's specific issues and specific nails, and now you fall traditionally typically in the bucket of having not one kind of a low resource issue. You could have a low resource in data, like I kind of explained a little more, but then you could also have low resource and heterogeneity in compute, and you can have all of these problems together, and that leads to new trade-offs. So let me just explain a trade-off now, for instance. So if you have a bunch of clients that you're doing this kind of distributed learning with, and some clients are more powerful and some clients are less powerful from a computational resource perspective, then what is known is there is a trade-off of being unfair to the less powerful clients, right? Because your model would be more biased and less performant on these less powerful clients. And we're moving into that world right now for LLMs where powerful clients are using their liberty to use as much power as possible, and that is leading to even stronger trade-offs of unfairness on the low resource settings. So this is another thing that needs to be taken care of, how to make things more fair. So I hope I've explained with some sprinkling of examples and also elaborated on the nature of the problem not being like a single line, but there's many aspects to it.
Thank you, Pradeep. I take away many points from what you said, including that low resource can mean many different things, and it's very complex to decide what exactly you mean by this. And that there are new types of federated learning methods that expand beyond what we traditionally understood, and these may be more applicable across these more complex settings. Thank you very much for these comments. So let's move on to our second panelist, who is Professor Tapratesh Sethi, who's a professor of computational biology and a founding lead at the Center for Excellence in Healthcare at the IIIT in Delhi. His research comes from a medical background, bridges clinical AI, computational biology, and digital health to create interpretable and ethical AI for population-scale health applications. So, my question to you is, what lessons from computational biology and clinical AI can inform ethical data sharing in federated settings? Go ahead.
Thank you, Gautam. It's my pleasure and delight to be here and fantastic discussion so far. I'll bring a slightly clinical angle to this discussion as well. That's my background and also one of the things we keep in the center when we are building models. The first thing is purpose. I think as institutions, we are not corporations, large big corporations with infinite resources. So we always perhaps ethics also involves are we bringing some benefit at the end of the day to the patients and to the doctors. So that means that essentially when we are building these federated learning models, outcomes, patient outcomes, and the purpose needs to be central, which essentially means that keeping the question first in the center and the purpose first is a very important thing we all need to agree on, especially when we build federated learning models. And why is this important? A very simple example is harmonization. Typically, we tend to think about interoperability and harmonization as building architectures which will enable syntactic interoperability, maybe some semantic interoperability. But what about operational interoperability? For example, we may have the same meaning of the word sepsis, but what does the onset of sepsis mean in different clinical settings? Now, some centers may say when the SOFA score crosses a certain threshold, but when was that certain score measured? Was it a real-time measurement? Was it a measurement with some time delays? So what we need to also bring in these models is some metadata around these operational definitions and agree around those. And there are some lessons that already exist, for example, OMOP, common data models, and such kind of initiatives where we can actually create such operational definitions when we create use cases. Then is risk scoring, as Professor Hartley also mentioned towards the end. It's difficult to ensure 100% privacy. And we have to weigh how much are we willing to give away in terms of utility and privacy. Specific example in case if we go to FDA and we have to show inclusiveness of our models, in order to be inclusive, we have to actually show outputs and outcomes on every little small subset of the patients, right? So in some way we are compromising privacy there because we are getting smaller and smaller getting to smaller and smaller sections of the population with the higher risk of re-identification in that subset. So where do we make that trade-off when we are actually trading off privacy with utility and then also inclusion? Um, Dr. Praneeth brought up the question of equity very nicely, and I think that also applies when we are building these models where we can have large hospitals collaborating with small hospitals, and that's very commonplace in all our in all our research projects. We might have a large tertiary care center and some smaller centers, and we run the risk that when we train such models, even in the federated learning setting, we might end up models getting biased by the large sample size. So how do we prioritize information value and not just sample sizes? I think that's another aspect, that we don't create models which will only end up benefiting a certain kind of segment of the population which is served by a certain large hospital. Validation out of distribution, I think, is something that everybody talks about, and just I want to bring that up as well, that federated learning offers us that opportunity, that we keep some out of distribution sites, and these sites also can be kept out temporally so that we know how well would our models generalize, and then of course apply strategies such as round robin evaluation, build a model on one, take it to the other, bring it back and see how well does it perform. So I think I'm running out of time, but I think a couple of more last important points that I would like to make is consent in all these scenarios should be treated as a living object. As Professor Hartley said, there will be models, there will be approaches, differential privacy, and models that will help mask privacy, but also there will be attacks. So as soon as we discover something going wrong, we should have mechanisms to withdraw consent and inform people that we have discovered this, so consent can be actually revoked. One last point is, I think, open sourcing, which may be counterintuitive, but I think we are a huge proponent of open source because it helps make things more transparent. Also a little bit of red teaming, and that's a direction that our lab is also moving in. Going forward, we work with ICU data sets with a couple of large hospitals, and we are building towards challenges that can be made openly available with some challenging questions, for example, inverting gradients or re-identification. So this kind of red treatment and ethical adversarial attacks could help improve the models. And I'll just take a pause there. Overarching thought process there being that I think at the end of the day, we have to really keep the patient benefit or operational benefit in the center of all this model building exercise. How do we do that? That part should also be a part of the conversation of federated learning. So thank you.
Thank you so much, Todd. There's a bunch of things that I will take away from what you said. One is architecture that facilitate operational interoperability is important. We need to weigh how much we need to give away. And consent is important. The ability to withdraw consent if one is informed of an attack is also important. And your point about open sourcing is also a very interesting point. That's certainly the direction in which most of us would like to go as scientists. So let me move on to our third panelist, who is Dr. Sanjay Wangmo, who's team lead Health Systems Unit of WHO Bangladesh. Dr. Wangmo has led multiple health governance and digital transformation initiatives in Bangladesh, focusing on data-driven planning and equitable access to care. So my question to you, Dr. Wangmo, is what are the key enablers and barriers in Bangladesh's healthcare system, and what are the country's future plans for health data governance? Dr. Wangmo.
Thank you very much for inviting me to this session. And good afternoon, good morning, good evening to the panel members and the participants. I'm not a digital health expert, so I feel very privileged to be among other professors on digital health and AI. But I can share some of the practical experience we face here in Bangladesh. As introduced, I'm Sanjay Wangmo, team lead for health systems with the WHO country office here in Bangladesh. So just to share some background status of digital health in Bangladesh, Bangladesh has made progressive status in digital health over the years. Their journey began back in 2010 when the country started shifting from paper-based health information system to digital platforms. Since then, the country has made some progressive modernization in the health sector. Now, to talk about what are the enablers for digital health in a practical setting, from the experience of Bangladesh, political commitment has been the strongest driving force behind Bangladesh's digital health journey. In addition, technology and connectivity have also played a big role. Today, internet access reaches both rural and urban areas of the country, and also mobile technology is expanding rapidly here in the country. At the same time, the role of private sector is very, very critical, and the private IT sector in the country has been active partner, helping the government to implement the government-led digital health initiatives in the country. Finally, as I work in WHO and we provide technical assistance with the help of our technical experts in the organization, we have observed that global and regional collaboration around this topic has provided valuable technical and strategic support to progress digital interventions in the health sector in the country. Within this setting, Bangladesh at this point is recognized as a first mover country under the Global Initiative on Digital Health, a recognition of the country's leadership and innovation in this area. However, despite the political commitment, technology and connectivity progress, and private sector contribution, there are critical challenges that country face. And I think this is a common challenge in many of the developing world are facing while moving towards digitizing health services. The major challenge remains within the governance and coordination setting. In Bangladesh, governance and coordination continue to be very weak. For example, within the Ministry of Health and the Family Welfare, there are several directorates, each run their own system of information. And also those are most of the time influenced by different partners implementing their own platforms, thereby resulting in fragmentation and limited interoperability. Workforce capacity is another major issue. Health workers in many of the developing countries, and similar is the case here in Bangladesh, does not have adequate literacy to use digital tools in their daily work. Therefore, the capacity building and competency and skill set building for the health workers in this area is highly critical. As the country is moving towards personal health record, so far, the country manages these health records through paper-based system, and they are progressing towards IT-based personal health records. And there is a critical need to strengthen citizens' digital literacy, especially since the national literacy rate is only around 79% according to the World Bank report. Above all, there is a need for strong governance to link the digital interventions in the Ministry of Health with other line ministries in the government setting. However, in reality, for now, many initiatives in a developing country like Bangladesh still remain project-based or pilot-driven, which lacks sustainable financing and therefore is a huge challenge that needs to be addressed for long-term success. Since I'm representing WHO today and to share with the participants here about WHO's contribution to digital transformation in Bangladesh, with WHO's technical support, Bangladesh has been able to develop two key policy documents, the Digital Health Strategy 2023, followed by the Digital Health Architecture Blueprint, which is endorsed this year in 2025. At the same time, in September 2025, WHO helped the Ministry of Health and Family Welfare here to organize a national convergence workshop, inviting participants from all the different actors and sectors in the country, which includes the government, the private sector, the civil society, and the development partners. This workshop actually supported reinforcing the multi-sectoral nature of digital health and uncovered the need for unified governance that goes beyond the health information unit of the Ministry of Health and Family Welfare. During that workshop, all the partners agreed that Digital Health Architecture Blueprint, which we have drafted, will serve as the guiding framework for Bangladesh's digital transformation, with governance as its key backbone. Therefore, while moving forward to support the progress in digital transformation, Ministry of Health and Family Welfare has initiated a discussion to establish a digital health authority as guided by the architecture blueprint. The vision is to make this autonomous body oversee all digital health activities under a coherent regulatory framework. It is also expected to ensure system interoperability, data privacy, cybersecurity. This agency is also expected to coordinate capacity building and to promote the ethical use of AI and digital tools, and to encourage public-private collaboration to strengthen. I would like to say, in order to progress to digital transformation very effectively, a strong governance built on ethics, trust, accountability, interoperability, and human capacity is very important, and therefore it's a true enabler for Bangladesh's next phase of digital health transformation. Thank you very much.
Thank you, Dr. Wanmu. And I take several things from your very nice presentation. One is that, of course, that you're recognized as the first mover in digital transformation, an important step for Bangladesh. But the other many commonalities between Bangladesh and India in terms of governance and coordination, which you have several directorates, as you said, each running its own system of information. There's considerable fragmentation in there. We, as you, need to strengthen citizens' digital health literacy and derive a coherent regulatory framework for everything that we need to do here as well. Thank you very much. So let me thank all of the speakers and that. There may not be time enough to circle back to you for a second round of questions. We need to go on to the final part of the program, which is the country spotlight, in this case for Thailand. And in my own work on modeling in public health, I've had occasion to visit and marvel at the Thai model for health systems evaluation in public health, as much that India in particular can learn from the public health system. And our speaker who will address privacy preserving AI and health data architecture here is Mr. Mark Landry, who's Program Officer of WHO Thailand, and he will provide a brief reflection on these questions. Mark, go ahead.
Sure. Can you hear me now?
Yeah, you're clear.
Okay, one second. Great. I know time is short, so I'll be very brief. So thank you, everyone. I just wanted to highlight what's happening in Thailand because I think this is a very good example of a learning laboratory and way forward for other countries to consider, but also learning by doing it right, not rushed. Of course, this country is well known for its amazing ability to take on the very deliberate approach for achieving universal health coverage, and this is I think part and parcel to the way that they understand patient-centric service delivery and really trying to enable some of the underpinnings for ethical appropriateness, way to deal with data, the way to respect the rights of citizens, including foundations such as the Patient Data Protection Act, looking at some of the way forward in a more holistic approach. And so just visually, you can see here the way that the electronic health record concept has been operationalized. But, we're not dealing with anything that is unusual to many low and middle income countries where there's a proliferation of apps and services. So even within the Ministry of Public Health here, there has been, a concerted effort now to harness the more than 100 apps that have been created, both software and also databases, mobile apps on individual patient service delivery applications, etc., and to create a more cohesive super app environment. Think WeChat in China. And this has become an important way forward. And so because of our transitional government that's currently kind of steering and directing some of the vision going forward, this idea of this super app is taking hold. And so all of this conglomerate of applications and services in a digital environment are being brought together under this MoreProm Plus super app environment. And this is being driven with optimization tools using AI. And then if we look at some of the bigger stepping back context, this is probably the most technical slide I will share. It's not important to understand it and recognize the details. But at the end of the day, standardization and the use of standards to create the enabling environment for effective health AI is essential, full stop. So I would argue that we have to support the adoption and adaptation and use of existing systems adhering to these standards to create that environments to ensure that we get the optimal use of these AI tools that are being proliferated, but also being adapted for these low and middle income country context. So, like most countries that are, thinking about this from a constructive, holistic way, we can see examples here of different kinds of hubs of intelligence that are being captured. And
Hi,
here in
Mark.
Thailand,
Your slides are not moving actually. Will you put on the slideshow mode if possible? It's stuck on
oh
the
my gosh,
page itself. Yeah.
I feel really ignorant about that. So pardon me. Hold on. I think I have the wrong one showing. Do you see my slide now with the Health Data Hub as DPI?
Yes, yes. Now it's perfect.
Okay.
Thank you.
I do want to go back to, I won't go back. There's no time. So let me just give you one very real recent example. This is with the injury surveillance system that has been evolving over the last actually 20 years. And so now they're creating an intelligence injury surveillance system, the I2S2, where they have realized that if we want to be more deliberate and precision-based service delivery and intervention targeted specifically for, in this case, road traffic injuries, that there has to be more unified approaches to bringing together information and intelligence from all of the necessary and reliable sources. And so you can see from this example, this is a pathway towards more robust, multi-sectoral, multi-stakeholder engaged approach to bringing different intelligence sources together using AI and using large language models to create the appropriate analytics to create more patient precision specific care pathways and eventually to reduce the burden of morbidity and mortality to road traffic injuries. Again, I mentioned before in different contexts, standards underpin the capacity and ability to deliver on more effective health AI solutions going forward. I'll just go directly to the last slide due to time. So, I think at the end of the day, in Thailand, they're recognizing that this is, a rebirth of technology advances and trying to bring together and harness all of the exemplar softwares and apps and solutions, drape over the guardrails of cybersecurity and patient data centric protection and security, but realize there are fragments and there are gaps. And I think this is where we have to have honest dialogue with countries about where they are and what they need to fill those from a policy, governance, architecture, and other dimensions. And I think this is an opportunity for all of us in this space to work towards co-creating these kinds of architectures as is happening here in Thailand, and a lots to share with others, but also to learn from others. And I hope this can reflect perhaps what our situations in other contexts as a way forward, that it's better to share these burdens and work together than try to sort out these solutions alone. Thank you so much.
Thank you, Mark. And we're well in time. I think there's one question that's in chat which I can address to, I think, to Annie. And then after that, I'll quickly sum up. So, and if you could address this, how can patient-led NGOs use AI for real-time health monitoring and data keeping for better health management for patients? This is asked by Manoj Singh.
Well, I think that's such a big question for the last 1 minute, right? There are so many different ways, and this is actually very exciting because AI is not a vertical tool, it's a horizontal tool. It can ask any number of questions, you can answer any number of questions as well. And it means that you actually have so many different ways to deploy these tools. And what's really important when you were saying here about for real-time health monitoring and data keeping, well, the thing is that I think we need real-time model monitoring. I think that's very important, and that will by monitoring the model and how it's performing and the feedback into those models and these red teaming and evaluation systems that you heard earlier on, it will have this very nice feedback loop where you ask models questions about your patients, maybe eventually connected to your EHR, etc. But with the feedback from the models giving either a clinical decision support or you name it, if we can give feedback to those models when they're doing the right thing or when their predictions are wrong, we can both improve the model as well as capture the data on how people are using the tools. So I think the real answer to your question is integration. And there is no one answer. And it's very important that it's needs-based. So I'm not avoiding the question. I'm saying that is a question that should come directly from the people using it. And it should be, how do you use AI in your everyday? Because they are using it already, right? They're sending patient data to all of these companies already because they're so desperate with the utility. And to build on how people naturally use it, to integrate it in that way and capture the information, and critically, when the information is wrong. That positive feedback loop can create continuous learning cycles, which are both informative to capture the data, but can also improve the models and how they learn. I hope that answered the question. Yeah.
Thank you. Thank you. That's it, I'm sure. So let me quickly summarize in about a minute and a half. I think Annie spoke about, it's going to be hard to summarize so many different strands that all of you have brought up. But Annie spoke about, I can speak about what struck me particularly. Annie spoke about tools that don't need AI expertise, but do need data and context. The idea of co-design and creating standards that work across multiple geographies. And indeed, the idea of distributed collaborative learning tools. And she introduced a number of broader questions, including of ethics. Praneeth Vapakuma said that low resources can mean many things. There are varieties of federated learning. The goal really should be optimality in terms of what the output ought to be. Professor Sethi spoke about harmonization, architecture that facilitate operational interoperability, and the nature of consent and what's important about consent. Dr. Wanmo spoke about the need for citizens' digital health literacy and the need for strong governance, and especially the WHO document from 2023 and 2025 in the Bangladesh context, the National Convergence Workshop, that were the large number of initiatives that have begun at the Bangladesh level. And Mark Landry spoke about the deliberate approach to universal health coverage in Thailand, which I think is really very important. The idea of a super app that could actually bring in together much of this information that is otherwise fairly well distributed. The importance of standards for enabling environment, as well as multiple promises and gaps that exist in the current system. With that, we've come to the end of this particular program. I'd like to thank all of you. I'd like to thank Annie. I'd like to thank all the panelists we had here. I'd like to thank you for both the insights that you provided here, as well as to keeping in time and making these very insightful and short input to our deliberation. And I'm sure that everyone who's listening to this particular webinar will take away many things from what you've said. Thank you very much, and thank you, KCDH-A.